Hello, my name is Charles Osejo, and my Panther ID is 6169463.
Hi, my name is Gustavo. My ID number is 6515625.
Hello, my name is Gabriel De Ostos. This is Lab 4 on op amps. We are in course EEL3110C. My Panther ID is 6206253, and we are part of Lab Group 9. So, viewing activity 1, we were, through this task, forced to get a generalized understanding of how op amps work and how current is distributed along the different voltage supplies, be them the inverting and non-inverting, or the voltage supply and from the negative and positive terminals. So viewing the schematic over here, we were tasked with finding all the different currents denoted on the diagram. All of these currents proved to be exceedingly low, with the exception of the voltage supply loop. And this makes sense as there is no supply voltage within the inverting and non-inverting loop. And that works to show that there is an extremely high impedance at the input terminals. That means, and consequently, there's negligible input current through those areas. And then through the power supply terminals, drawing current depends on the operation and load. That's why we resulted with a value, at least in the multisim, with 30 milliamps. Viewing our actual results, our experimental data showed that we got a output voltage of 5.81 millivolts, which is approximating the 6.4. There might be some equipment or experimental error that led to this discrepancy. And the rest of the currents were appearing as zero, and that makes sense as the theoretical value is in the nanoamp range, which our detector was not, our multimeter was not sensitive enough to detect. That concludes activity 1.
In activity 2, we were tasked with building the following circuit under a set of conditions and calculating the voltage output. The conditions we chose were VDC is equal to 5 volts, VCC is equal to 15 volts, and VEE is equal to negative 15 volts. This is an example of the circuit built on multisim, and the operational amplifier is op-amp 741. Pin 3 is the non-inverting input, and this is where the voltage source enters, which is 5 volts. Pin 7 and pin 4 are the negative and positive power supply, and these values are 15 volts and negative 15 volts. Pin 2 is the inverting input, and pin 6 is where the voltage output comes through. In order to solve for voltage output, we had to use computer simulation and experimental analysis. We found that through computer simulation, the voltage output was 5 volts. We did this by connecting the multimeter on the location of the voltage output and connected it to ground, and it gave 5 volts. When doing the same thing for the experimental analysis, we got that it was 4.3 volts. An error is expected, so this was good.
Activity number 3. In this activity, we had to set up two op-amps with this configuration. So we have the first op-amp works as a buffer or like a voltage follower, and the second op-amp works as an inverting amplifier. We have to set up this circuit for three conditions. The first one is the one that we have here, where R1 is equal to R2. So when R1 is equal to R2, we obtain that the gain is 1. So basically, we're going to have at the output, which is VO2, we're going to have the same voltage that we have at the DC, at the voltage DC that we have at the beginning. So we're gonna have the same voltage but with the signal inverted. That means that it's gonna be negative 5. In this case, we obtain negative 4.998, and yeah, that's what this circuit in this case is doing. It's just following using like the first op-amp to reduce the noise, so it keeps the same voltage that we're giving to the op-amp, and then the second op-amp will invert the signal. For the second condition, R1 is going to be greater than R2, and R2 is the resistance of the negative feedback. If the resistor of the negative feedback is less than R1, what we obtain is that the second voltage is gonna decrease. The signal is gonna be inverted, but the voltage is gonna decrease. This, as we can see, having a resistor less than R1 in the negative feedback, it will reduce the signal that we get at the end of the second op amp. And for the last condition, we obtain that the gain will basically be like the the maximum gain that we can supply to the circuit. It's basically gonna the saturate the pump. So what we're getting, it's negative 14 0.117 volts at the end of the second op amp. And in all the cases, the first op amp works as a voltage follower. With this, we can uh, see that op amps can be used in different circuits to reduce the noise um, that can other components in the circuit add to the general structure of the whole circuit.